Hi, I'm Jeff Fayako, a student at Kenyatta University, and welcome to this episode whereby I'm going to show you how to derive the equation of an ellipse. So it is quite easy, but it is somehow challenging to derive this equation. So we are all aware that the equation of an ellipse is x squared over a squared plus y squared over b squared is equals to 1. Now from this equation you can actually see that x squared over a squared plus y squared over b squared is equals to 1. X squared plus y squared is equals to 1. When we look at the numerators, this is actually the equation of a unit circle. X squared plus y squared is equals to 1. That is the equation of a unit circle. Now, when we look at an ellipse, we can conclude that an ellipse is just we can see that an ellipse is nothing but just a unit circle that has actually been stretched outwards. By definition, we usually define an ellipse as a set of points on the locus whose sum of distance from two fixed points, which is usually the two foci, is a constant. That is the definition of an ellipse. For instance, I want you to consider this. We have the two fixed points foci 1 and foci 2. And we take another point on the loci, let's say P. When we add this distance from F1 to P and then from P to F2, this one should give us a value that will be equivalent to another point, let's say K. When we add this plus, when we add F1 plus F2, that should give us the same value as F1 P F2. Now let's consider another point, say M, that is lying on the longest diameter. Another point M that is lying on the longest diameter of the foci. Now we have said that when we add F1 to K, then from K to F2, that should give us a constant value. So this is the same as when we add F1 plus M back to F2. Now I want you to look at this in this way. Let's say we have F1 and we have B on this other side. When we come straight, let's say now we don't have F2. When we come direct from F1 to B, we will actually have moved from the whole of this distance. Now the returning distance from B back to F2, this distance, the return distance, is equivalent to the one from F1 to A. So you can conclude that that constant that we are talking about is nothing but just the longest diameter of the foci, this one. So that constant is, we get that constant by adding the distance from A to B, which is the longest distance of the foci. Now I have labeled my foci, my my coordinates. Now I have A, and then I have B, and then I have the two foci, and I have another point P, X, Y. Now when we add this distance A to B, we have said that is the constant. That constant will be this one, negative A, we add to this other A, and that constant will be 2A. Now let's consider this point P on the loci that is lying on this circumference of the ellipse. Now F1 P, that one will give us, when we add those, should give us X plus, that should give us X plus C plus Y. And from P to F2, that should give us X minus C plus Y. Now when we come to calculate the magnitude, it will be the root X plus C into bracket squared plus Y squared plus the other root, which is X minus C squared minus Y squared is equals to the constant. Now we bring the second root to the other side. We will get root X minus C squared plus Y squared is equals to 2A minus root X minus C squared minus Y squared.